All right, so last video we set this problem up. This video we solve. So remember, we set up our problem with our flow diagram, and then we said, here's the general balance equation. Now, the key thing here that I want you to remember is that every time you use the general balance equation, it needs to be applied to a specific thing. So we can always write balances, and when we write balances, there are always one type of balance we can write, and that is the total overall system balance. That can always be written. Okay, and then we can then write balances on each species or each component of the system. So for this particular problem, we have three balances. We have the overall balance, we have a balance on methanol, and we have a balance on water. Okay? And the reason that we write multiple balances is because it's going to give us an equation. Each of these gives us a different equation. It's important because we need a system of equations to solve this problem. Okay, now we did the general balance equation in general for all mass, but it's actually going to hold true for A and B in this particular problem. So let's start by writing the total overall system balance. So remember that input number 1 is going to be in purple, input number 2 is going to be in green, and our output is going to be in blue. So I'm going to flip over to the other side so I have some room. So first things we're going to do is we're going to write our overall balance. And our overall balance says that the input to the system must equal the output. Well, if we go back to our flow diagram, we have two inputs, mass 1 and mass 2. We only have one output, that's mass 3. So if we have M1 and M2 going in and M3 coming out, the overall balance is as simple as writing M1 plus M2 equals M3. And that's it, right? That's very easy, right? To think, okay, 2 inputs in, 1 input out. So if we plug some numbers in, let's do that. We know we have 200 grams coming in input stream 1 and 150 grams coming in input stream 2, which means that M3 at the end of the day must equal 350 grams. Okay? Now, I know you can do that without writing out these equations. But the key thing to these problems is going through this process, because this right here, this input equals output, changes for every single problem you do. So knowing the general balance equation first is extremely important to writing this segment. All right, so that's the overall balance. Let's now write a balance on A. All right, if we go back to our flow diagram, we have methanol, which is A, present in the first stream, the second stream, and the third stream. But what the key thing here is this mass, this M1 and this M2, these are total masses. This is not the mass of methanol, right? So what we actually want is the mass of methanol in 1, the mass of methanol in 2, and the mass of methanol in 3. So let's write that out really quick. So if we're going back to our input equals output, same thing is going to apply here. Let's write it out so we remember. Input equals output. Then the mass of methanol in 1 plus the mass of methanol in 2 has to equal the mass of methanol in 3. Okay, so A representing methanol, numbers representing the stream. Now, what do we know about this mass right here, this mass of methanol? Well, we don't know this number, but we know M1 and we know XA1. So can we insert a relationship here to get this number? Well, we know that XA1 is defined as MA1 over M1 because this is the total mass and this is the mass of just methanol. This is extremely powerful because if we rearrange this, we know that the mass of A1 equals XA1 M1. This is critical because we're going to do this for each of these species throughout the entire semester. When you are balancing A, these subscripts need to have an A. We know that there's a relationship between mass composition and total mass, and this is that relationship. So this whole formula right here can be rewritten, and it can be written in the following way. We can say the composition of methanol in stream 1 times the total mass will give us that number. We can do the same thing in stream 2. We can say the composition of methanol times the total in stream 2 will give us the composition of methanol in stream 3 times mass 3. Okay? This is critical. The step to go from here to here is absolutely critical. So take a pause if that didn't make sense. Now, what are we actually looking for? We're looking for what's in this stream. Now, with the total balance up here, we already found M3. This means that this equation can be used to solve for XA3. So let's do some real quick algebra. Let's make sure we understand this. If we want to get XA3 by itself, we say XA1 M1 plus XA2 M2 divided by M3 equals XA3. Okay? So all I did was do from here to here was do algebra. I divided everything by M3, and it's everything, not just one term, everything. Okay? So what we can do from here is plug in some numbers. Why not? We've got it, right? We've got everything that we need. So let's find the composition of methanol in stream 3. That's going to be the 40% methanol that was found in the original stream, and that's grams of A per gram total, times the 200 grams total. That's total down here. I'm running out of space. There we go. Plus the 70% of A in the second stream times the 150 grams, and all of that is going to be divided by the 300, let me move up, 350 grams we found for M3. So that's going to give us a number, and we can say from here that the composition is going to be 0.529 grams of A per gram total in the final. Okay, there we go. So there's a balance on A. We were able to find the composition of methanol in the stream. Now there are two ways that we could find the composition of water in the final stream. The first way is to understand that 100% of the output stream must be methanol and water. So what that means is that XA3 plus XB3 must equal 1, right? So if we go back to our flow diagram, we can only have methanol and water. That's it. That's all we can have. So the total of these two must be 100%. So if they're in decimal form, that means XA3 plus XB3 must equal 1. If we use this, XB3 will be equal to 0.471 grams of B, which is water, per gram total. That is the easy way to finish this problem. The other way that we could finish this problem is to do the balance on B. And we're going to do it because this is how you do back substitution in these types of problems. Let's write a balance on B. We know input equals output. And I'm not going to use my colors just in the interest of keeping this video a little bit shorter. But we know that the mass of B in 1 plus the mass of B in 2 has to equal the mass of B in 3. If we use what we know about mass fractions up here, we can do the same thing here. We can say xb1 m1 plus xb2 m2 equals xb3 m3. We now want this one right here. So if we solve for xb3 is going to be xb1 m1 plus xb2 m2 divided by m3. Okay, and I do want to see this algebra. That is going to be critical in this class. I do want to see the algebra. Now, if we plug in all of these values, xb3 we will find is equal to 0.471. So this is a way of checking your answer. The other thing you could do here is you could plug in all the values in this line. And this side of the equation must equal this side of the equation. And that would be back substitution. Okay, so there are two ways once you've found one of the compositions, because there are only two species here. So let's do a real quick recap. When we solve mass balances, we can always write a total balance on the overall system. Then we can write a balance on each species. Each time we do this, we always start with the general balance equation, and then we write it out with our subscripts. So this is an overall balance, so you don't see A or B because it's not one species, it's everything. When we balance on a species like A, same thing, general balance equation, but now all the subscripts have A's. We use relationships like mass fractions to translate this into numbers we actually know. We make sure that we do our algebra, and then we solve. And then from here, there are multiple ways to finish the problem, and that's critical, okay? This extra balance here on B, we didn't have to do, but this is how you would do your back substitution. And that's going to close us out. I know these are slightly longer videos, but it's really important to understand how to solve these types of problems. If you have questions on this, please ask in class.